9.1, reference triangle and reciprocal trig functions. Okay, and this involves the unit circle. I'm actually going to get a laser pointer here so I have something to point with. A unit circle. And a unit circle, by definition, is a circle that has a radius of 1. Okay? Well, I'm going to put a point on this unit circle right where that radius meets the circle, and I'm going to call it point P. And I'm going to draw in the triangle here. All right, and then we're going to have a theta, angle theta, that it makes with the positive x-axis. Now, we have SOHCAHTOA, and remember, SOHCAHTOA is a way to remember the trig functions of sine, cosine, and tangent, where the opposite side of this triangle is the side opposite theta, adjacent means next to, and then the trig functions are sine of theta is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is the opposite over the adjacent. All right, what I want to do is apply this to the unit circle. Okay, and so, for example, let's look at the sine. Now, the sine of theta is opposite over the hypotenuse, and if the hypotenuse is 1, then the sine of theta is just the value of the opposite here. But notice that the opposite side goes up to the y. This is really the length, the distance from the x-axis of this point, or saying a different way, it's the y-coordinate. Okay, so the sine of theta is really just the y-coordinate of the point. Similar arguments will lead to the cosine. Cosine is adjacent over the hypotenuse. The adjacent is just the length away from the origin, and that's really just the x-coordinate of the point. So really, the sine and cosines are just the x and y coordinates of a point on the unit circle. Okay? And this is why the cosines and sines are always less than 1, because by the triangle inequality, the sides of the triangle have to be less than the hypotenuse, so these have to be less than 1. And that's why the sines and cosines are always less than 1. Okay, now, what are the sines and cosines? What are the signs of these functions in each quadrant? Well, looking at the first quadrant, if I I'll just put my laser pointer. Okay, the x and y coordinates of this one, the x is positive and the y is also positive. So that means the cosines and sines are all positive. Okay. In quadrant 2, the x coordinate is negative and the y coordinate is positive. So the cosine is negative and the sine is positive. In quadrant 3, both coordinates are negative, negative x, negative y. So both sines and cosines are negative. Remember, these are just the x and y coordinates. And in quadrant 4, the x coordinate is positive, the y coordinate is negative, so therefore the cosine is positive and the sine is negative. Okay, let's do some examples. So in this example, I want to find the sine of theta, all right? Well, here's the point, and this is really the hypotenuse of a triangle. Opposite side being, or check that, I'm sorry. One side is being on the axis, and I'm just going to sketch in the opposite side here with the angle theta. All right. And this is really something that we call, I should probably have a blue right there to signify that side of the triangle. This is really called a reference triangle. A reference triangle is a triangle where the angle is less than 90 degrees. The angle that it makes with the origin is less than 90 degrees. Okay. Okay, so now if I want to, if I have the length of this side, which is -3, x coordinate, the length of this side is 4, the y coordinate, what we need is the hypotenuse. So I'm going to operate Pythagorean theorem on this to find the length of the hypotenuse, and that turns out to be 5. Okay, so the length of the hypotenuse is 5. And I needed that because to find the sine function, which is the opposite over the hypotenuse, I needed the length of the hypotenuse. All right, so I calculated that. And then the sine, which is the opposite over the hypotenuse, that's going to be 4 over 5. All right. All right, let's do another example. Find the cosine of theta. I'm going to draw sketch one in, and I want to have it here. I'm going to have the point being -6, -2. And I'm going to draw a ray from the origin. That's going to be the terminal side of the angle. All right. And the angle actually is this. Okay, but I'm going to use a reference triangle. So I'm going to sketch in my y there. Then the angle, yeah, that's a reference triangle, and there's my angle right in there. Reference triangle is a triangle where the angle with the origin, okay, where the terminal side comes from the origin, that angle is less than 90 degrees. Okay, I want to find the cosine. I need to find the length of the hypotenuse. I need to find C. So I'm going to use Pythagorean theorem again. And that becomes 36 plus 4, which is 40. And then I'm going to take the square root of 40. Square root of 40, I'm going to break up into the square root of 4 times the square root of 10. And now I can write this as 2 root 10. Okay? And then I want to find the cosine. And the cosine is the adjacent over the hypotenuse. The adjacent is -6. Okay? -6. And the hypotenuse is 2 root 10. All right? Now we want to simplify this. Couple things. We could reduce the 6 over 2, and we also don't like to leave roots in the denominator. So I'm going to multiply top and bottom by root 10, special form of 1, and then the denominator is going to become root 10 times root 10, which is 10, times 2 is 20, and the numerator is just -6 root 10. And then finally, I can reduce this to be negative. I can reduce that to a 3. I can reduce that to a 10. And there's my answer. Okay. Next example. Given that theta is in the fourth quadrant and the sine is -3 over 5, find cosine of theta. All right. Well, here's my unit circle. Okay. I'm going to sketch in the reference triangle. All right. Now it's in the fourth quadrant, so I'm just going to draw it in like that. Okay. And I know that the sine is opposite over hypotenuse, okay? And if I remember that the cosine is positive and the sine is negative in the fourth quadrant, so therefore we have this negative sign out here, -3 over 5. The negative has to go with the y, the opposite. The negative has to go with the opposite. So it's -3 over 5, okay? Now, it is true, and you can keep this in mind too, that when we find the hypotenuse, it's always going to be positive. The hypotenuse will never be negative. The x-coordinates and y-coordinates, those can be negative, but the hypotenuse is always positive. Okay, keep that in mind. All right, well, what I need to find is x, all right? Because x is adjacent over hypotenuse. Looking ahead, I'm going to need x. So, I'm going to operate Pythagoras on this thing. And doing a little math, we find that x is equal to 4. And I know it's positive 4 because the cosine is positive in the fourth quadrant. All right, so this is positive 4. So now when I write the cosine being adjacent over hypotenuse, we know it's 4 over 5, and that's our answer. If it were in the second or third quadrant, I would tack on a negative sign to that 4 because we could see that it has to be negative if it's over here. But over here, we can see by inspection that the x-coordinate must be positive. Okay, now I want to introduce the reciprocal trig functions. I want to make a little table, all right? And the trig functions being cosine, sine, and tangent, okay? Now we want to introduce some reciprocal trig functions. 1 over cosine. 1 over cosine is defined to be the secant. 1 over the sine is defined to be the cosecant function. And 1 over the tangent is defined to be the cotangent function. Okay, so we have 3 new trig functions: the secant, cosecant, and cotangent. And you're going to have to memorize this. A secant is 1 over the cosine, a cosecant is 1 over the sine, cotangent is 1 over the tangent. Okay? All right, let's apply this to the opposite, the adjacent, and the hypotenuse sides of a triangle, okay? If the sine is the opposite over the hypotenuse, and the cosine is 1 over the sine, that means that the cosecant is the reciprocal. If it's a reciprocal of the sine, it's the reciprocal of the opposite over hypotenuse, or hypotenuse over opposite, okay? If the cosine is adjacent over hypotenuse, and the secant is the reciprocal of the cosine, that means that the reciprocal is the reciprocal of adjacent over hypotenuse, or hypotenuse over adjacent. And then if the tangent is the opposite over the adjacent, and the cotangent is the reciprocal of the tangent, then the cotangent is the reciprocal of opposite over adjacent, or adjacent over opposite. All right? Now, you don't necessarily have to memorize, cosecant is a hypotenuse over opposite and stuff like that. There's no like SOHCAHTOA for this. But if you remember that the cosecant is the reciprocal of the sine, then you can determine this from SOHCAHTOA, etc. And same thing with those. Let's apply this to this triangle. All right. Now, first of all, the sine. If the sine is the opposite over the hypotenuse, opposite of theta is 5, hypotenuse is 13. And so we get 5 over 13. And then the cosecant, which is the reciprocal of the sine, will be 13 over 5. All right. And if you wanted for some reason to memorize that the cosecant is hypotenuse over opposite, you get that from here too. Hypotenuse over opposite. Okay. All right. Cosine is adjacent over hypotenuse, so that's going to be 12 over 13. And then the secant, which is the reciprocal of the cosine, will then be 13 over 12. Okay, and then tangent, which is opposite over adjacent, is going to be 5 over 12. And then the cotangent will be the reciprocal of that, or 12 over 5. Okay. All right. Given that theta is between pi over 2 and pi, and the sine is 8 over 17, we want to find all 6 trig functions. Well, we already found one. We really have to just find the other 5, right? So I want to put in a unit circle. And pi over 2 is up here, pi is over here. So we know that we're going to be in the second quadrant, okay? So I'm just going to sketch in a triangle. Now I know that so I'm going to put a reference triangle in there with an angle of theta. And I know that the sine is 8 over 17, which is opposite over hypotenuse. So I know that this side, the opposite side, is 8, and the hypotenuse is 17. Note that 8 is positive because it's positive in the second quadrant. All right, sines are positive in the second quadrant. Hypotenuse is always going to be positive. All right, now what I really need to find is this side. If I want to find all the trig functions, I'm going to need this side. So by Pythagoras, x squared plus 8 squared is equal to 17 squared. Operating my calculator a little bit, I'm going to get a value of 15. Okay, and that 15 is going to be negative 15 because in the second quadrant, the x coordinates are negative. So I'm just going to write that in as negative 15. Okay, by inspection, we can see that has to be negative 15. All right, let's start finding some trig functions now. Cosine, adjacent over hypotenuse. Adjacent, negative 15 over hypotenuse of 17. And I'll just pull the negative sign out front. All right, let's see what's next. Tangent. Tangent is opposite over adjacent, which is 8 over negative 15. And again, I'm just going to pull that out. All right. What about the cosecant? Pause. See if you can come up with the cosecant. Okay, a couple ways to get this. You could say, well, it's the reciprocal of the sine, so it's going to be hypotenuse over opposite, or you can just go directly from 8 over 17 to get 17 over 8. Okay. Secant, which is the reciprocal of the cosine. Reciprocal of the cosine, that will then be hypotenuse over adjacent. Okay. Or once again, you can just go right from there. and we'll get negative 17 over negative 15 written as this. And then finally the cotangent will be the reciprocal of the tangent, adjacent over opposite, which turns out to be negative 15 over 8. And you're done. All right. Next, what quadrants can theta lie in if the sine of theta is greater than 0 and the cosine is less than 0? All right, well, remember the quadrants. Okay, 1, 2, 3, 4, just to get a visual. And remember that the cosines and sines are nothing more than the x's and y's. So the sine being the y coordinate, the cosine being the x coordinate. Well, in which quadrant are the y's positive and the x's negative? Well, the y's are positive up here, and the x's are negative over here, so that leads us to quadrant 2. All right, what quadrants can they lie in if the sine and the tangent have the same sign? All right, well, remembering that the tangent is defined to be the sine over the cosine, okay? And if we know that the sine and the tangent have the same sign, they're either both positive or both negative. That means going from the right side of the equation to the left side of the equation, the sign cannot change. Therefore, the cosine has to be positive. All right, if the signs for the sine and the tangent, if they're both positive, that can only be true if the cosine is positive. If they're both negative, that can only be true if the cosine is positive. So the cosine must be positive. All right, well, but the sines and tangents, they can either be positive or negative. Let's take the case where they're both positive. If both the sine and the tangent are positive, the sine being the y coordinate and the cosine being the x coordinate, which quadrant does that lead us to if the y's and the x's are both positive? Quadrant 1. Okay, what about the case when they're both negative? Both the sine and the tangent are negative. Okay, so the sine is negative. The cosine, remember, has to be positive. Well, in which quadrant are the y's negative, but the x is positive? Y's negative, x is positive. That leads us to quadrant 4. One more example. What if the cotangent and secant have opposite signs? All right, remember what a cotangent is. A cotangent is 1 over a tangent, and a tangent is a sine over a cosine. Therefore, the cotangent is cosine over sine. And remember, a secant is a 1 over a cosine. All right, now, I know that the cotangent and the secant have opposite signs. That's the criterion up here, right? If they have opposite signs, that means that the sine must be negative, okay? Because if the secant is positive, that means the cosine is positive. And if the cosine is positive and the cotangent is negative, that means the only way that can happen is the sine is negative, okay? And vice versa. If the cosine is negative, the cotangent is positive, that means the sine has to be negative also. So the sine must be negative. Okay. Okay, but the cosine can either be positive or negative. So we have two cases again. If the sine is negative, as it must be, but the cosine is positive, what quadrant does that lead us to? Y is being negative, x is being positive, y is being negative, x is being positive, quadrant 4. If the sine is negative and the cosine is also negative, what quadrant does that lead us to? Sine's negative, cosine's negative, that leads us to quadrant 3. Okay. All right. So 9.1, we introduced the unit circle and a little bit about that, and then we define the reciprocal trig functions, which is similar to SOHCAHTOA. At least we use SOHCAHTOA to analyze it. And then we can also talk about where the quadrants come in. All right, where they are in certain quadrants. All right. You're now in position to try the 9.2 practice problems.